December 16th, 1944, 0300 hours. Losheim Gap, Belgium. Oberst Friedrich August von der Heydte pressed his field glasses against his eyes, watching American positions across the snow-covered valley through the pre-dawn darkness. His First Parachute Regiment had been ordered to break through what intelligence described as a lightly defended sector held by inexperienced troops. The Wehrmacht officer expected to find standard infantry positions, foxholes, perhaps some light anti-tank guns. What he saw instead made his blood run cold. In the pale moonlight, reflecting off fresh snow, he observed something that made no tactical sense. The Americans weren't just dug in. They had transformed the entire valley into a killing ground that defied everything von der Heydte knew about defensive warfare. Concrete bunkers that hadn't existed 72 hours earlier. Anti-tank ditches 12 feet deep, cutting across every avenue of approach. Entire sections of forest reduced to interlocking fields of fire. Miles of barbed wire. Not the simple obstacles he'd encountered in Russia, but elaborate entanglements, incorporating metal stakes driven deep into frozen ground. Most disturbing were the bridge demolition charges he could see even from 800 meters away, professional installations that would drop every crossing point into the Our River the moment his forces advanced. This wasn't the work of infantry. This was the signature of American combat engineers, and von der Heydte had learned to fear that signature more than any other unit in the American arsenal. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you're watching from today. Within 6 hours, von der Heydte's regiment would suffer 47% casualties, attempting to cross a valley that American engineers had turned into an impenetrable fortress in less than 4 days. The men who built these defenses weren't specialists pulled from rear areas. They were combat engineers, soldiers who fought with rifles in one hand and carried demolition charges in the other, who could construct a Bailey bridge under fire in the morning and assault a fortified bunker that same afternoon. The German High Command had made a catastrophic miscalculation about these units. In 1942, Wehrmacht intelligence classified American engineer battalions as support troops, non-combat personnel who built roads and cleared obstacles behind the fighting. By 1945, German commanders would testify that they feared engineer units more than armored divisions, more than airborne troops, more than any other formation in the Allied order of battle. This transformation from dismissed support troops to the most dreaded adversaries on the Western Front is a story of innovation, brutality, and the systematic destruction of German tactical doctrine by men armed with explosives, bulldozers, and an American approach to problem-solving that German officers found incomprehensible. The mathematics of engineer capability exceeded anything the Wehrmacht had encountered. A single American engineer battalion, numbering roughly 640 men, could emplace 5,000 anti-personnel mines in 12 hours, construct 300 meters of fortified positions in 24 hours, or reduce an entire town to rubble in less than a day. More significantly, these same soldiers could transition from construction to combat instantly, fighting as effective infantry while retaining their specialized capabilities. The German military tradition separated combat troops from support personnel with rigid distinctions that had worked effectively in previous wars. Combat engineers existed in the Wehrmacht, but they were specialized assault troops, pioneers who supported attacks but rarely defended positions and never operated as line infantry. The Americans had created something different entirely, hybrid soldiers who eliminated the distinction between combat and support. Every engineer private received the same infantry training as line troops. 16 weeks of basic combat instruction, including marksmanship, tactics, and close-quarters battle. Then came an additional 12 weeks of specialized engineer training covering demolitions, construction, mine warfare, and obstacle reduction. The result was a soldier who could function as a rifleman in a firefight, then immediately shift to clearing a minefield or demolishing a bridge under fire. German commanders initially viewed this hybrid approach as inefficient, diluting combat effectiveness by burdening soldiers with too many skills. The first encounters would prove this assessment catastrophically wrong. Lieutenant Heinrich Becker, commanding a company of the 7th Army's 19th Infantry Division, wrote in his combat diary about an engagement near Aachen in September 1944 that fundamentally changed his understanding of American engineer capabilities. His company had been ordered to counterattack American positions that had penetrated the Siegfried Line's outer defenses. Intelligence reported the penetration was held by an engineer battalion, and Becker's superior officer assured him they would face minimal resistance. The engineers would withdraw when confronted by determined infantry assault, standard doctrine for support troops caught in combat positions. Becker's assault began at dawn with 2 companies, roughly 300 men advancing against what they believed was a disorganized American position. The first indication something was wrong came when German troops entered the kill zone and discovered the American engineers had established interlocking fields of fire that demonstrated professional infantry training. Machine gun positions were mutually supporting, carefully sighted for grazing fire across the approaches. Foxholes were properly spaced and connected by communication trenches. The defensive layout wasn't improvised by support troops. It was textbook infantry doctrine, executed by soldiers who clearly understood defensive warfare at an expert level. Then the mines began detonating. American engineers employed mine warfare with a sophistication that shocked German troops who had invented many of the techniques. The minefields weren't simple, linear obstacles. They were complex patterns, mixing anti-personnel and anti-tank mines, arranged to channel attacking infantry into pre-registered kill zones where machine guns and mortars could achieve maximum effect. Becker's lead platoon lost 32 men in the first 5 minutes, shredded by a combination of mine explosions and precisely timed machine gun fire. The survivors who pushed through the minefield encountered another innovation that would become the engineer's signature. The Americans had prepared the buildings and rubble of Aachen for demolition with professional efficiency. As German troops moved through seemingly clear streets, entire structures collapsed on top of them, buildings wired with explosives and detonated by engineers who had calculated exactly when advancing troops would reach specific points. Becker watched 2 squads, 40 men, disappear under tons of collapsing masonry and controlled demolitions that demonstrated mathematical precision. The engineers weren't just defending, they were using the battlefield itself as a weapon, transforming every structure, every street corner, every piece of terrain into a potential death trap. When Becker's depleted company finally closed with American positions for direct assault, they discovered these support troops fought with the aggression and skill of elite infantry. The engineers didn't withdraw when attacked. They counterattacked, using their intimate knowledge of the terrain they had fortified to conduct devastating flanking movements. Small teams of engineers moving through communication trenches they had dug themselves appeared behind German positions with flamethrowers and satchel charges, weapons that standard infantry rarely carried, but engineers employed as standard equipment. Becker's company was destroyed in less than 2 hours. Of the 300 men who began the assault, 68 survived to retreat. The American engineers, later identified as companies from the 1st Infantry Division's Engineer Battalion, reported 14 casualties. The kill ratio of more than 20-1 against trained Wehrmacht infantry shattered German assumptions about American engineer combat effectiveness. More disturbing to German commanders analyzing the engagement was the realization that the engineers had built the defenses that destroyed Becker's company in less than 36 hours, transforming open ground into a fortified killing ground faster than German units could respond to the penetration. The speed of American engineer operations defied German logistics and tactical planning. Wehrmacht engineers, when conducting major fortification work, required days of preparation, detailed planning, and extensive supply lines. American combat engineers operated with a tempo that made defensive preparation nearly instantaneous. The difference lay in doctrine, training, and equipment that reflected fundamentally different approaches to warfare. German military thinking emphasized careful planning and methodical execution. American engineering doctrine stressed speed, improvisation, and overwhelming material superiority. Each American engineer company deployed with organic equipment that German engineers could only requisition through division-level supply channels. Every company had dedicated dump trucks, bulldozers, air compressors, concrete mixers, and welding equipment. The engineers didn't wait for supply. They carried their construction capability with them as organic equipment. More significantly, American engineers trained to operate at night, using the darkness that traditionally halted military construction. German units, hearing the distinctive sound of American bulldozers and air compressors working through the night, learned to expect transformed terrain when dawn arrived. Positions that were open ground at dusk became fortified strongpoints by sunrise, complete with overhead cover, interlocking fire lanes, and obstacle belts that would require hours to breach. Hauptmann Klaus Ritter, an intelligence officer with the 5th Panzer Army, compiled reports on American engineer activities during the autumn of 1944. His analysis, captured after the war, revealed the growing German fear of these hybrid soldiers. Ritter wrote that American engineers represented a fundamental challenge to German tactical doctrine because they eliminated the distinction between combat and support that German planning assumed. Traditional Wehrmacht tactics called for bypassing support units to strike combat formations. American engineers made this impossible because they were simultaneously both support and combat troops, capable of defending as effectively as attacking, building as efficiently as destroying. Ritter's report identified specific engineer capabilities that German forces had no effective counter for. The Americans' use of explosives exceeded anything Wehrmacht pioneers employed. Standard American engineer loads included composition, C2 demolition charges, shape charges for penetrating concrete, thermite grenades for destroying equipment, and white phosphorus for creating smoke or causing casualties. Each engineer squad carried enough explosives to destroy a railway bridge, reduce a building, or crater a road. They employed these weapons with a casualness that German officers found disturbing, as if high explosives were routine tools rather than specialized munitions. The Bailey Bridge system exemplified American engineer capability that Germans found incomprehensible. British designed but employed extensively. By American engineers, the Bailey Bridge allowed construction of vehicle-capable bridges using prefabricated panels that required no special tools or skills. German intelligence first encountered Bailey bridges during the Italian campaign and initially dismissed them as temporary expedients unsuitable for serious military traffic. By Normandy, they recognized their error. American engineers could erect a Bailey bridge capable of supporting Sherman tanks across a 60-foot gap in less than 12 hours, often under fire. The bridges appeared overnight, replacing structures German forces had spent days demolishing. Wehrmacht demolition experts calculated that destroying a stone bridge required tons of explosives and careful placement to ensure complete destruction. American engineers would bypass the destroyed bridge entirely, erecting a Bailey bridge 200 meters away, while German forces still defended the original crossing point. The speed defeated German defensive planning based on controlling traditional crossing points. The Americans simply created new crossings faster than Germans could destroy existing ones. Oberst Hans Schmidt, commanding the 11th Panzer Division's Engineer Battalion, studied American bridge construction techniques in detail after his division's retreat across France. His report noted that American engineer battalions could construct or destroy with equal efficiency, shifting between roles without pause. A unit building a bridge in the morning would demolish it in the afternoon if tactical situations changed, then build a replacement somewhere else by evening. This operational flexibility made American engineers unpredictable and extremely dangerous. The German fear of American engineers reached new levels during urban combat, where engineer capabilities proved decisive. Traditional German urban defense doctrine relied on turning cities into fortresses, using buildings as strong points and streets as death traps. This worked effectively against conventional infantry, who had to clear buildings room by room, a slow and costly process. American engineers approached urban combat differently, employing demolitions and mechanical equipment to bypass German defensive plans entirely. In Aachen, the first major German city to fall, American engineers pioneered techniques that would terrorize German urban defenders throughout the remaining war. Rather than clearing buildings systematically, engineers would blast entrance holes through walls using Bangalore torpedoes or beehive charges, allowing infantry to bypass defended doors and windows. Buildings deemed too dangerous to clear were simply demolished, engineers using precisely calculated charges to drop structures on defenders inside. The psychological impact was devastating. German soldiers defending a building would hear American engineers working outside, placing charges, and know they had minutes to escape before tons of rubble buried them alive. Those who remained to fight discovered that American engineers had no hesitation about bringing down entire city blocks to eliminate resistance. Lieutenant Otto Werner, who survived the defense of Aachen as part of the 246th Volksgrenadier Division, testified in post-war interrogations about the terror of facing American engineers in urban combat. Werner described hearing the distinctive sound of American air compressors and jackhammers, tools that engineers used to drill holes for demolition charges in concrete structures. The sound meant engineers were preparing to demolish the building, and defenders had to choose between immediate withdrawal or certain death under collapsing masonry. Werner's testimony revealed that German troops learned to evacuate buildings the moment they heard engineer equipment, abandoning carefully prepared defensive positions rather than risk being buried. The Americans exploited this fear systematically, sometimes running compressors and drills as psychological weapons without actually demolishing buildings, using the sound alone to clear German defenders. The engineers' use of bulldozers in combat roles particularly horrified German defenders. American engineer units employed armored bulldozers, standard construction equipment fitted with armor plate and operated by combat engineers trained to work under fire. These machines pushed rubble into streets to create barriers, knocked down damaged buildings to deny German snipers positions, and most terrifyingly, buried German defensive positions under tons of debris while defenders were still inside. Feldwebel Ernst Hoffmann, an infantry platoon sergeant defending Cologne in March 1945, watched American engineers employ an armored bulldozer to reduce his company's defensive position in less than 30 minutes. The bulldozer, operated by an engineer who ignored German small arms fire bouncing off the armor plate, systematically pushed the rubble of destroyed buildings over German foxholes and fighting positions. Hoffmann's men had to choose between abandoning their positions or being buried alive. Those who remained and tried to fight discovered that rifle fire couldn't penetrate the bulldozer's armor, and the machine's operator simply continued working while bullets sparked off the steel plate, protecting his cab. Hoffmann escaped with 11 men from a company that had numbered 96 that morning. The rest were either buried under bulldozed rubble or killed trying to retreat across open ground. The bulldozer itself was undamaged, its engineer-operator reporting back to his unit to request another load of fuel. The casual efficiency of the operation, treating combat as a construction project to be completed on schedule, demonstrated the American engineer mindset that German soldiers found alien and terrifying. These weren't soldiers who happened to know engineering. They were engineers who happened to be soldiers, approaching combat with the same methodical problem-solving they applied to building bridges or clearing obstacles. The minefield warfare that American engineers practiced represented another dimension of capability that Germans struggled to counter. Wehrmacht doctrine treated mines as defensive weapons, laid in prepared positions to protect static lines. American engineers employed mines offensively, using them as tactical weapons that could be emplaced and removed rapidly as situations changed. The speed of American mine laying shocked German forces accustomed to slower, more methodical mining operations. An American engineer company could lay 1,000 anti-tank and 2,000 anti-personnel mines in a single night, creating instant obstacle belts that channeled German movements into kill zones. More frustrating for German forces, these same engineers could clear the mines just as quickly when American forces needed to advance, using specialized mine-clearing equipment and techniques that the Wehrmacht lacked. The M1 mine detector, a portable electronic device that could locate buried mines, allowed American engineers to clear paths through minefields in hours, while German pioneers relied on slower manual probing techniques. American engineers also employed innovative mine types that confused German clearance efforts. The M2 anti-tank mine used a metal case that was easily detected, but engineers increasingly employed wooden box mines, M5 mines, with minimal metal content that German detectors couldn't locate. The psychological effect of knowing minefields existed, but being unable to detect them paralyzed German movement, forcing lengthy manual probing of any suspected mined area. Oberst Wilhelm Brandt, commanding a Panzer Grenadier Regiment during the Bulge Offensive in December 1944, encountered American defensive mining that stopped his regiment's advance for 3 critical days. American engineers, given less than 48 hours warning of the German offensive, had mined every road, trail, and open field across 10 square kilometers. Brandt's forces, attacking on schedule, ran immediately into mine belts that destroyed vehicles and killed dozens of men. His engineers began clearing operations, but discovered the Americans had booby-trapped their own minefields. Mines were wired together so that attempting to remove one detonated others. Dummy mines concealed real ones underneath. Anti-personnel mines surrounded anti-tank mines, killing engineers attempting clearance. The clearing operation that should have taken hours stretched into days, while American forces reinforced their positions and called in artillery on the stalled German columns. Brandt later calculated that fewer than 200 American engineers working for 2 nights had created obstacles that delayed a regiment of 3,000 men for 72 hours. The force multiplication effect was devastating. Those same 200 engineers, when finally engaged in direct combat as Brandt's forces overran their positions, fought as effective infantry, inflicting casualties disproportionate to their numbers before conducting an organized withdrawal. The engineers hadn't just delayed the German advance, they had fought it to a standstill, then extracted themselves intact to build new defenses elsewhere. The American engineers' bridge demolition capabilities created constant frustration for German forces attempting any kind of mobile warfare. Wehrmacht doctrine relied on rapid movement, using rivers and canals as defensive barriers when withdrawing, crossing them quickly when advancing. American engineers made both impossible by their systematic destruction of bridges across entire theaters of operation. Unlike German demolition techniques that often left bridges repairable with moderate effort, American engineers destroyed bridges completely, using precisely calculated charges that dropped spans into rivers and often cratered the approaches to prevent Bailey Bridge construction. The demolition of the Ludendorff Bridge at Remagen, though it failed initially when the bridge didn't collapse on March 7th, 1945, demonstrated the dilemma facing German engineers. American forces had captured the last intact Rhine crossing, but German engineers spent days trying to destroy it with artillery, aircraft, and even frogmen carrying demolition charges. The bridge, damaged by the original failed demolition, finally collapsed on March 17th, but by then American engineers had constructed pontoon bridges and ferries that maintained the bridgehead. The Americans could build bridges faster than Germans could destroy them, reversing the traditional defensive advantage that river barriers provided. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Major Franz Dietrich, Operations Officer for Army Group B, analyzed American engineer bridge operations in a report dated February 1945. His assessment concluded that American engineer units possessed mobility and capability that made traditional defensive planning obsolete. Dietrich noted that a single American engineer battalion could simultaneously operate in multiple locations, one company building a bridge while another demolished obstacles, and a third fought as infantry. The organic transportation and equipment allowed engineers to shift rapidly between roles and locations, appearing wherever the tactical situation demanded. German engineer units, by contrast, operated centrally controlled and required extensive coordination to move or shift missions. By the time Wehrmacht engineers could redeploy to meet a new situation, American engineers had already completed their task and moved to the next objective. The tempo difference meant American forces maintained constant momentum while German defenses were always reacting, always behind the operational curve. The flamethrower warfare that American engineers practiced represented perhaps the most psychologically devastating aspect of their combat operations. While other Allied forces employed flamethrowers, American engineers integrated them into their tactical doctrine with a frequency and efficiency that terrorized German defenders. Each engineer battalion included specialized flamethrower teams, soldiers trained to employ both portable flamethrowers and mechanized flame weapons mounted on tanks. The engineers didn't use fire as a specialty weapon reserved for specific situations. They employed it routinely, treating flame as another engineering tool for clearing obstacles and reducing fortifications. Bunker complexes that would require hours of infantry assault could be neutralized in minutes by engineer flamethrower teams who understood exactly where to direct fire for maximum effect. The technical knowledge engineers possessed about structures and materials made their use of flame weapons devastatingly effective. They knew which parts of fortifications were vulnerable, where ammunition was likely stored, how fire would spread through ventilation systems. This expertise transformed flamethrowers from terror weapons into precision instruments of destruction. Unteroffizier Karl Brenner, defending a concrete bunker complex in the Heydte forest during November 1944, experienced American engineer flamethrower tactics firsthand. His position, part of the Siegfried Line's deep defenses, had been designed to withstand artillery bombardment and infantry assault. The bunker featured 3 feet of reinforced concrete, interlocking fields of fire and protected ammunition storage. Brenner's squad of 12 men felt secure in their fortress until American engineers arrived. The attack began not with infantry assault, but with engineers systematically studying the bunker complex, identifying ventilation shafts, drainage systems, and structural weak points. Brenner watched through his firing slit as American soldiers calmly walked around his position, apparently unconcerned about defensive fire, making notes and pointing at various features. Then the flamethrowers came. The engineers didn't waste fuel spraying fire randomly at concrete walls. They directed streams of burning liquid into specific openings, ventilation shafts and drainage points that Brenner hadn't considered vulnerable. The burning fuel, a jellied gasoline mixture that stuck to surfaces and burned at temperatures exceeding 2,000 degrees, poured through the bunker's ventilation system. Within seconds, the interior filled with choking smoke and searing heat. Brenner's squad had two choices: remain inside and suffocate, or burn, or evacuate into the open where American infantry waited. They chose evacuation. All 12 men surrendered, their impregnable fortress reduced to an oven by engineers who understood its construction better than its designers. The engineer use of explosives in combat situations went far beyond standard demolitions. American combat engineers carried and employed an array of specialized charges that allowed them to breach any obstacle or fortification. Bangalore torpedoes, metal tubes filled with explosives that could be pushed through wire obstacles or under fortifications, allowed engineers to clear paths through defenses that would take infantry hours to penetrate. Beehive charges, shaped explosives designed to blast holes through concrete walls, turned fortified buildings into death traps as engineers punched entry points wherever they chose, bypassing defended doors and windows. Satchel charges, canvas bags filled with composition explosives, became the engineer's signature weapon for destroying everything from machine gun nests to armored vehicles. German defenders learned to fear the sight of American engineers carrying satchel charges because it meant their positions were about to be demolished regardless of how well fortified. The engineers approached bunkers and strongpoints with a methodical casualness that unnerved German troops. They would place charges precisely, withdraw to safe distance, detonate, then immediately move forward to assault through the breach. The entire process, from approach to assault, often took less than 5 minutes, faster than German defenders could react or call for support. Lieutenant Gustav Hartmann, commanding a platoon in the 76th Volksgrenadier Division during the defense of the Roer River dams in February 1945, witnessed American engineers reduce his company's defensive line in less than 30 minutes using systematic application of explosives. Hartmann's positions had been prepared over weeks, incorporating concrete bunkers, log-reinforced fighting positions, and elaborate wire obstacles. His company of 96 men occupied what commanders assured him was an impregnable defensive sector. The American attack began with engineer reconnaissance teams identifying every defensive position. Then came the explosives. Bangalore torpedoes cleared lanes through wire obstacles in seconds. Beehive charges blasted holes through bunker walls. Satchel charges destroyed machine gun positions. The engineers worked with assembly line efficiency, one team clearing obstacles, while another breached fortifications, while a third provided covering fire. Hartmann watched his defensive line collapse position by position, each strong point demolished by engineers who seemed entirely unconcerned about defensive fire. His soldiers shot at the Americans, scoring hits that should have stopped them. The engineers kept working, even wounded men completing their demolition tasks before seeking medical attention. When Hartmann's position was finally overrun, he had lost 63 men. The American engineers reported 8 casualties, none fatal. The mathematical efficiency of their assault, reducing prepared defenses with minimal losses, demonstrated a level of tactical competence that German officers found impossible to counter. The Rhine crossings of March 1945 showcased American engineer capabilities at their absolute peak. The Rhine represented Germany's last major defensive barrier, a river averaging 300 meters wide with strong currents that German commanders believed would delay Allied advances for weeks. The Wehrmacht demolished every bridge and prepared defensive positions on the eastern bank, confident that crossing operations would be slow, costly, and vulnerable to counterattack. American engineers made these calculations irrelevant through an application of resources and capability that overwhelmed German defenses. At Remagen, where the Ludendorff Bridge's capture provided the first bridgehead, engineers worked under constant German artillery fire and air attack to reinforce the damaged structure and build additional crossings. Within 48 hours of the bridge's capture on March 7th, American engineers had constructed 2 pontoon bridges and established ferry operations, creating redundant crossing capacity that made the eventual collapse of the Ludendorff Bridge tactically meaningless. At Oppenheim, where Patton's Third Army crossed on March 22nd, engineers conducted assault river crossings with a speed that shocked German defenders. The first wave crossed in assault boats at night. By dawn, engineers had pontoon bridges operating. By afternoon, heavy traffic, including tanks, was crossing on tactical bridges that German intelligence had estimated would take 3 days to construct. General Major Wilhelm Decker, commanding the 53rd Corps, defending the Rhine sector, reported to Army Group B headquarters with barely concealed despair about American engineer operations. His message, intercepted by Allied intelligence, revealed the psychological impact of engineer capability on German morale. Decker wrote that American engineers had made the Rhine crossing inevitable through their ability to construct bridges faster than German forces could destroy them, to clear obstacles more rapidly than defenders could emplace them, to overcome every defensive advantage that terrain and preparation provided. His defensive plan had assumed crossing operations would require days of preparation, allowing time for German reinforcements and counterattacks. The Americans completed their crossings in hours, engineers building the infrastructure while infantry established bridgeheads simultaneously. The operational tempo made German defensive doctrine obsolete. By the time German forces could organize coherent responses, American engineers had already established permanent bridges capable of supporting entire armored divisions. The Rhine, Germany's greatest natural barrier, had been overcome through engineering capability that turned the river from an impassable obstacle into a minor delay. The specialized equipment that American engineers deployed represented technological advantages that Wehrmacht forces couldn't match. Mine detectors, bulldozers, air compressors, welding equipment, portable generators, all standard issue for American engineer units, gave them capabilities far exceeding German pioneers. The M-29 Weasel, a tracked cargo carrier that could traverse mud, snow, and rough terrain where conventional vehicles bogged down, allowed engineers to work in conditions that would halt German operations entirely. American engineers used Weasels to deliver supplies and equipment across terrain the Wehrmacht considered impassable, building bridges and clearing obstacles in locations German commanders believed impossible to access. The armored bulldozers, modified construction equipment fitted with armor plate and operated by combat engineers, became symbols of American material superiority. German troops, shooting at these machines, watched rifle fire spark harmlessly off armor while the bulldozers continued their work, pushing obstacles, clearing rubble, or burying defensive positions. The psychological message was clear. American engineers possessed resources so abundant they could armor construction equipment for combat use, treating specialized machinery as expendable tactical tools. Hauptmann Ernst Müller, an intelligence officer, compiling reports on American engineer equipment for 7th Army headquarters in April 1945, concluded that material superiority alone didn't explain American engineer effectiveness. Müller's analysis noted that German forces possessed similar equipment in small quantities, but lacked the doctrine, training, and logistical support to employ it with American efficiency. The Americans integrated their equipment into standard operations, using bulldozers and mine detectors as routinely as rifles and hand grenades. German pioneers, when they could obtain specialized equipment, treated it as precious resources to be carefully husbanded and employed only in critical situations. This difference in approach meant American engineers could work at tempos impossible for German units, solving tactical problems through immediate application of whatever resources the situation required. Müller's report concluded with a stark assessment. American combat engineers represented the ultimate expression of American industrial warfare, combining unlimited material resources with practical training and aggressive doctrine to create soldiers who could build or destroy with equal efficiency, fight or construct on demand, and operate at tempos that made conventional defensive planning worthless. The final months of the war demonstrated the complete reversal in German attitudes toward American engineers. Units that encountered engineer battalions reported facing elite troops whose combat effectiveness exceeded standard infantry. German intelligence began tracking engineer unit movements with the same attention given to armored divisions, recognizing that engineer. Deployments indicated major Allied offensive preparations. The presence of American engineers transformed tactical calculations because these units brought construction capability that could alter terrain overnight and combat capability that could overwhelm prepared defenses. The psychological impact on German troops was profound. Soldiers who had fought bravely against infantry and tanks spoke of engineer attacks with barely concealed fear. The combination of explosives, expertise, mechanical equipment, and aggressive infantry tactics created an enemy that seemed unstoppable, capable of demolishing any defense through sheer technical competence and overwhelming resources. Feldwebel Otto Schmidt, a veteran infantryman who had fought on the Eastern Front before transfer west, compared facing American engineers to combat against Soviet forces in a letter captured in April 1945. Schmidt wrote that Russian attacks were terrifying. Through their mass and disregard for casualties, human waves that could overwhelm through numbers, American engineers were terrifying in different ways through their cold efficiency and technical superiority. They didn't attack in waves. They dissected defenses systematically, identifying and destroying each position with minimal wasted effort. Schmidt described watching an engineer team reduce a company strongpoint. The Americans moving from bunker to bunker with assembly line precision, placing explosives, destroying positions, moving to the next target. The entire operation took 15 minutes from first contact to complete penetration. Schmidt's company of 87 men suffered 64 casualties. The American engineers reported 3 wounded. The disparity in effectiveness, the sense that German defenders were fighting soldiers who possessed unfair advantages in training, equipment, and doctrine, destroyed morale more effectively than casualties. German troops could accept losses in fair fights. They couldn't maintain morale when facing enemies who approached combat as engineering problems to be solved through technical application. The bridge at Remagen, despite its eventual collapse, became symbolic of the engineer capability gap between American and German forces. After the bridge's capture, German high command threw everything available at destroying it. Artillery bombardment, Luftwaffe airstrikes, even V-2 rockets and frogmen carrying demolition charges. American engineers, working under constant attack, reinforced the damaged structure while simultaneously building pontoon bridges and establishing ferry operations. The contrast was stark. Germany's most advanced weapons couldn't destroy one damaged bridge that American engineers worked continuously to maintain. Meanwhile, those same engineers built replacement crossings using prefabricated components and standard procedures, creating redundant infrastructure faster than German forces could damage it. The Remagen bridgehead expansion demonstrated engineer impact on operational outcomes. Within 10 days of the bridge capture, American engineers had constructed 7 tactical bridges across the Rhine in that sector, transforming a single penetration into a major bridgehead supporting multiple divisions. The engineering achievement made German defensive efforts meaningless through sheer construction capability that exceeded anything Wehrmacht forces could match or counter. Oberst Hans von Luck, commanding the 21st Panzer Division's Reconnaissance Battalion, encountered American engineers during the final defensive battles in central Germany. His unit, reduced to battle group strength through months of combat, was ordered to delay American advances across the Weser River. Von Luck planned to use the river as a defensive barrier, demolishing bridges and defending crossing sites with his remaining troops. American engineers made his plan irrelevant through construction capability that rendered natural obstacles meaningless. Von Luck's forces demolished 3 bridges on April 6, 1945. By April 8th, American engineers had constructed 5 new bridges, bypassing the destroyed crossings entirely and establishing bridgeheads before German forces could concentrate against any single crossing point. Von Luck attempted to counterattack one bridgehead and discovered American engineers defending it fought with the skill and determination of elite infantry, repelling his attack while continuing to expand bridge construction. His battle group, veterans of France, Russia, and North Africa, couldn't dislodge combat engineers who treated battle and construction as simultaneous activities. Von Luck withdrew, reporting to division headquarters that further resistance was pointless. American engineers could build faster than Germans could destroy, fight better than standard infantry, and operate at tempos that made conventional defensive tactics obsolete. The human cost of engineer operations, often overlooked in histories focusing on infantry combat, reflected the dangerous nature of their dual mission. American combat engineers suffered casualty rates comparable to or exceeding infantry units because they fought while conducting high-risk construction and demolition work. Engineers clearing minefields faced constant danger from explosives they were trying to remove. Engineers building bridges under fire worked exposed to enemy observation and artillery. Engineers assaulting fortifications with demolition charges close to point-blank range, where defensive fire was most deadly. The engineer units accepted these risks as inherent to their mission, approaching dangerous tasks with professional competence that sometimes appeared to German observers as reckless disregard for safety. General Lieutenant Fritz Bayerlein, commanding Panzer Division, noted in post-war interrogations that American engineers seemed willing to take casualties that German units would consider prohibitive if it meant completing their objectives. Bayerlein described watching engineer teams continue working under artillery fire that should have driven them to cover, soldiers completing bridge construction or mine clearing, while wounded men received treatment nearby, and work continued without pause. This determination, combined with technical skill and superior equipment, made American engineers nearly impossible to stop through conventional defensive measures. The final irony of German fear of American combat engineers lay in the Wehrmacht's own pioneer tradition. German military history included elite assault engineer units, pioneers who had distinguished themselves in both world wars through courage and technical expertise. The Americans had taken the concept further, creating hybrid soldiers who combined the combat effectiveness of assault troops with the technical capability of construction specialists, then multiplying this capability through industrial resources that equipped every engineer with specialized tools and weapons. What German pioneers did occasionally as specialized missions, American combat engineers did routinely as standard operations. The difference wasn't courage or skill. It was doctrine, training, and resources applied systematically across entire engineer branches. By 1945, German officers acknowledged that American engineers represented military capability their forces couldn't match. The combination of technical training, combat aggressiveness, and unlimited material support created soldiers who could accomplish in hours what German units required days to complete, if they could complete it at all. In May 1945, as Germany surrendered, captured Wehrmacht officers were questioned about their combat experiences and which Allied forces they had found most formidable. The responses, compiled in interrogation summaries, revealed unexpected patterns. When asked to identify the most feared Allied units, German officers consistently mentioned American combat engineers alongside elite formations like airborne divisions and armored units. General Major Rudolf Freiherr von Gersdorf, former Chief of Staff for 7th Army, stated in his interrogation that American engineers had proven more dangerous than specialized assault troops because they combined multiple capabilities that forced German defenders to simultaneously counter infantry attacks, demolition operations, and rapid construction. Von Gersdorf's assessment concluded that facing American engineers meant confronting enemies who eliminated defensive advantages through technical solutions, who built faster than defenders could destroy, who fought as well as they constructed, and who approached war as an engineering problem to be solved through systematic application of resources and expertise. The transformation of German attitudes toward American combat engineers from dismissal to dread took less than 2 years of combat. In 1943, Wehrmacht intelligence classified engineer battalions as support troops. By 1945, German commanders feared engineer units more than most combat formations. The change reflected hard lessons learned through encounters where engineers fortified positions overnight, demolished defenses instantly, built bridges faster than Germans could destroy them, and fought with effectiveness that exceeded standard infantry. These hybrid soldiers, armed with explosives and bulldozers, represented American military philosophy at its most effective. Overwhelming material superiority combined with practical training and aggressive doctrine. They didn't just support combat operations. They defined them, transforming battlefields through construction and destruction, conducted simultaneously, turning terrain itself into a weapon through technical expertise that German forces couldn't counter. The men who built the bridges that carried Allied armies into Germany, who cleared the obstacles that blocked advances, who reduced fortifications with systematic efficiency, earned respect from enemies who had initially dismissed them. That respect, born from brutal combat experience, reflected recognition that American combat engineers represented something new in military affairs. Soldiers who could build or destroy on command, fight or construct as situations required, and operate at tempos that made traditional defensive warfare obsolete. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.